Hello, and welcome to Scientific Methodology. This goes along with the readings from the Boundless book, Chapter 1, Section 1, and the OpenStax book, Chapter 1.1. So as you can see, there are lots of ways to look at what we refer to as the scientific method. Now, of course, there isn't truly one method that all scientists follow, and as you can see from both the diagrams on the left and the right, even the scientific method can have differences in terms of how they choose to look at each of the steps and the vocabulary that they use. But if you notice, both of them start with making an observation. One then says consult prior knowledge, one says ask a question, but then they both come back to a main point, which is formulate a hypothesis. In case you're not aware, a hypothesis is an educated guess based on prior experiences or prior knowledge. We'll tend to follow from here the method on the right. We'll then make a prediction based on that hypothesis, do an experiment to test that prediction, analyze the results. If the hypothesis seemed to be correct, you might go ahead and report the results. If the hypothesis was incorrect, you would definitely go back, try again, formulate a new hypothesis, and repeat the procedure. Now, while this particular model on the right does say go through one test and then report your results, that's not really accurate. What most scientists would do is make continual checks, repeat the experiment multiple times to make sure the results are consistent prior to reporting the results. So looking at the parts of this controlled experiment, we have a series of different components. Each of them are listed on the bottom. So you're going to make an observation, do background research about that, construct the hypothesis. You're going to test your hypothesis with an experiment, analyze the results, and then draw conclusions. So pause the video for a moment while you go ahead and figure out with Jenny's little synopsis here which component of that experiment correlates to each of the parts. Okay, so now that you've taken time to do that, let's go ahead and see, as Jenny states about spraying the vegetables, hopefully you had for that one, that this is the constructed hypothesis. For the next one, hopefully again you've taken the time to read it. If not, pause here and take the time to continue with the rest of them. This is test with an experiment. After 1 week she's comparing. This part is analyze the results. Jenny wonders about protecting her plants. That is ask a question. She determines that her homemade solution was just as effective. That's drawing the conclusion. And of course, when she went to the library, that was doing the background research. And you will be working with each of these steps by analyzing some of your own problems. So you might ask, why should we care about this? Who cares? Yeah, I solve problems, but really I don't need to study biology for that. But there are lots of practical examples that have been performed by scientists over decades, if not centuries, and they have affected real change for you in your life, including seatbelt reform. When I was a child, you didn't have to wear a seatbelt, but after multiple hundreds to thousands of studies indicated that people who had not worn seatbelts were far more likely to have life-threatening injuries, then the law was modified. Same thing with cigarette studies. After decades of research and tens of thousands of studies, finally in the 1980s, cigarettes were required to have the warning label about being carcinogenic. Same thing with environmental studies leading to regulations for what exactly it is that industry can put out into the air, can dump into the water to try to keep us safe. And the same thing in the 1980s when they finally banned chlorofluorocarbons, or CFCs, because of the destruction that these gases were having in the ozone layer. And And in your own life, there are areas that you might want to investigate, and certainly things that professional scientists are studying at the time. Are the antibacterial soaps more effective than traditional soaps? And conversely, are there risks from using antibacterial soaps? And last year, the national chain Bath and Body Works got rid of the triclosan, the antibiotic that they had been putting in their soaps, because they were convinced by the studies that the antibiotic that they were putting in was causing more harm than good. Other questions might be, does a small amount of sodium lead to hypertension? We all know that eating lots of salt can lead to high blood pressure. How about a moderate amount? And one that I had looked at independently, does taking niacin prevent the need for prescription medication for high cholesterol? I have congenital high cholesterol and tried taking the flush-free niacin and found from my own personal experience it didn't work. Now, of course, I can't publish that, but if I were to conduct multiple studies over a long period of time, that's exactly what they do in situations like that. So, what are these components of a scientific study? One thing is that you have to have a control group. You have to have one group that remains outside of the testing conditions. So if you want to try to see if niacin is going to have an effect on cholesterol, you'd have to have a group that is not taking niacin. The independent variable is the one thing that you want to study. So take that niacin example. The niacin pill itself would be the independent variable. I'm going to subject some people to niacin and some people would be taking something else. That's the independent variable. And then the dependent variable is the thing affected by the change in the independent variable. So that would be the cholesterol level in the example that I gave with the niacin. And whether you recognize it or not, you probably use some modification of the scientific method every day. Everybody has problems, and so think about a problem that you have been facing. You're going to write out the steps of that experiment. If you're in class, you're going to be doing that right now. If you're doing this in the hybrid version, then I'd like you to write out the experiment with each of those parts that you saw in the Jenny example, and you're going to bring that into class. So pause the video while you take a few minutes to do that. Okay, we're going to look at some more examples of just being able to recognize the observation of the problem, the control group, the independent variables, and so on. So take a moment and read about Homer, and then we'll go over all of these together. Okay, so now that you've paused the video and taken a few minutes to look at this, what was the initial observation or problem? And of course, it was that there's green slime in the shower. The control group, remember that's the one outside of the experimental conditions. That's the part of the shower that he sprayed with water. The independent variable, remember that's the part that he wants to see if it's going to have an effect or not. So what did he experiment with? And that's the use of the coconut juice. And the dependent variable, what should have changed as a result of the independent variable? That's the dependent. It depends on what was done. And that's the presence of the green slime. So what should Homer's conclusions be? Of course, the coconut juice did not seem to be effective against the green slime. So, of course, if you're going to experiment with humans, there are some additional components that you have to look into. And one of these is a placebo. If you give somebody a medication or a beverage that they expect is going to have some result, they might experience it just because they think it's going to happen. And so some portion of the group, generally about half, will receive the actual experimental condition, that independent variable, and half will receive a placebo. You might have heard that, the placebo effect. They'll get essentially a sugar pill. And that's just to make sure that the effects are real and not psychological. A blind study means that the participants don't know if they're getting the real deal or if they're getting the placebo, because if they know, they might still be subject to the same psychological conditions. And in a double-blind study, neither the participants nor the researchers know who's getting the placebo and who's getting the actual treatment. This is recorded somewhere, but the experimenters, while they are experimenting, do not know who is receiving which, and this eliminates bias on the part of the researchers. So let's try another example where we're going to look at the blind and double-blind component as well. So pause the video and take a few minutes to read about Krusty and analyze and identify the components of the experiment. So now that you're back and you've taken a few minutes to look at these, the control group here, again, this is the component that was removed from the experimental conditions, is test subject A. The independent variable, this is the thing that you're changing to see if it's going to have an effect. That is which itching powder is used. And the dependent variable, what's going to change as a result of changing the independent variable. That's how long the itching lasts. So was this blind? Was it double blind? Or was it neither? And it was blind because the subjects didn't know which itching powder they received, but Krusty did. Was there a placebo? And if so, what was that placebo? And there was no placebo. They all got itching powder. Had he given somebody, say, baby powder and there was a test subject C, that could have been the placebo, but Krusty did not design his experiment with one. And did the data support the claims? And indeed, they did. The experiment might not be valid because he only did it one time and only had 2 subjects, but it said that it would increase itching by 50%, and indeed, 45 minutes is 50% longer than 30 minutes. So now that you've had this introduction, go back to the OpenStax book and try the questions on page 17. That'll give you a little bit additional practice with this. If I've managed to work out the system, there's a practice quiz in Boundless if you log in there. There might be additional practice in OpenStax. I'm still trying to get access to that software for you as we pilot the new program. And then in Blackboard, you'll take a quiz on scientific methodology. Your average score will be recorded. You can take it as many times as you would like. So good luck with that and keep working through it until you got it.